A warm welcome, grade 3. So lovely to be with you again today. And I'm so happy to be able to be doing this. It's what I love to do. So welcome to your maths lesson for today. And I hope you're going to learn from it and enjoy it. Brought to you by WorksheetCloud, very proudly. And there is the email address that you need should you need to get a hold of me for any questions whatsoever. Right, so what I need to ask you now is to make sure that you have a pencil and paper ready so that when I ask you to do a couple of little calculations, you will be ready to do so. If you don't have that right now, then I recommend that you just pause the video, run and grab a pencil and a piece of paper or your book and shoot back to the computer, and you can just then carry on the video as per normal. I'll be waiting for you. Today's maths lesson is named Number Mixed Bag 2. And if you remember correctly, grade 3, as I mentioned to you yesterday, that I was going to be focusing on revising and practicing the skills we've learned over the last few weeks, because that's important to keep coming back to those things and not just leaving them for weeks on end, because you need to be refreshing your minds and practicing those skills so that they become second nature and you understand them really, really clearly. So that's why I call it a mixed bag, because it has got a whole lot of activities and not just one kind of concept that we're dealing with. I'm dealing with a number of concepts that we've covered recently. But nothing begins in Mrs. Harmon's class without our maths riddles for the day. And we had a good old giggle with them recently, so let's keep that up because it's good and healthy to laugh. Right, the first one. What happens once in every minute, twice in every moment, and yet never in 1,000 years? Now, grade 3s, remember riddles are often have twists and turns, and it's only right at the end that you can see why they created this riddle in the first place. Has anybody got any ideas? What occurs once in every minute, twice in every moment, and yet never in 1,000 years? Well, it's the letter M, isn't it? Very funny. Next, what has a thumb and 4 fingers but is not alive? Well, I suppose you could say a statue. How about a glove? How do you make the number 7 an even number without using addition, subtraction, multiplication, or division? So without adding, subtracting, multiplying, or dividing, how do you make the number 7 an even number? What do you think? You just drop the 7. Would you take the S off 7 and you get even? Oh, those are quite corny, aren't they? Right, so what are we going to focus on today? Grade 3s is going to be similar to yesterday because I am building up on your skills and your concepts. So firstly, we're going to be focusing on the concepts covered so far, which I explained to you earlier. We're going to still look at 2 times 5 times 10 times 11 times tables, because I'm going to ask you the same tables in a different order, and I'm going to see if you can do the answers quicker than you did them yesterday, if you're timing them on a stopwatch or on a phone or something like that. We're going to be counting, we're going to be sharing and grouping, which is multiplying and dividing actually. We're going to look at word problems and fractions, and that's it in a nutshell. So here is your tables quiz, grade 3. 2 times, 5 times, 10 times, and 11 times. And once again, I'm going to ask you to please, if you don't mind, pause the video, and then you can time yourself while you're doing this. so that we don't have to make everybody wait, because everybody's going to do it at a different speed. So everybody now pause the video, and you're going to use your pen and a piece of paper to write down numbers 1 to 20, and then quickly as you can and as correctly as you can, you're going to write down the answers, and then we will mark them together. So 1, 2, 3, steady, go. Right, so now let's do the answers, because I'm assuming that you've paused the video and now we're going to do the answers together. So let's get going. 3 times 2 is 6. 5 tens, 50. 7 fives, 35. 3 tens, 30. 7 times 2, 14. 11 times 10, 110. And you know all the rules to these tables, because we did this a while ago when we did multiplication tables, guys. So it's now we're practicing those rules. You see, 4 times 2 is 8. 9 tens, 90. 8 times 11 is 88. Now 11 to 20, 4 times 5 is 20. 6 11s are 66, and we used to say clickety click because that's what it sounds like. 2 2s are 4. 12 5s are 60. 5 2s are 10. 12 2s are 24, you've doubled. 8 2s, doubling again, 16. 7 11s, 77. 6 times 5 is 30. And 12 times 10 is 120. Did you get them all right? Those, if you didn't get them all right, that doesn't matter. You're just going to take those that you had a bit of a struggle with, and you're going to focus on them and learn them again. Well done, guys. Excuse me. Okay, so now let's focus on counting. Counting is very important, because now we start to see patterns in number, and patterns are important when it comes to mathematics. Okay, and I'm going to show you now your number lines, building again on what we did the other day and seeing the patterns. Let's go. Right, we're counting in tens. Count along with me out loud, guys. That would be great. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Now, what we're going to do is we're going to see how this pattern develops, grade 3s. I'm going to now count in hundreds. So 100 is 10 times bigger than 10. So you will notice if we're multiplying 10 by 10, we're going to gain a naught each time. It's going to get a naught. So let's count in hundreds and see the pattern and how it relates to the one in yellow. 100, 200, 300, 400, 500, 600, 700, 800, 900, and plus 100 is 1,000. Now I'm taking you into the thousands where you're supposed to be going in grade 3, and it might take you a little while to clearly understand this, but we'll practice it often, so don't get worried if you're a little bit confused now. It will come. Be gentle on yourself. And 1,000 should I say, plus 100 is 1,100, and that's how we write it. Remember place value that we've looked at as well? The 1 in the thousands means 1,000. The 1 in the hundreds column means 100. Right, now we count in 2s and then 20s and then in 200s, and you'll see just how clever you actually are. And sometimes I'm going to push you a little bit to make you think a little bit out of the box, because how do we grow unless I push you a little bit? Okay, so let's count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. And of course you know that on a number line it just goes on forever and ever and ever, ever, but we have to stop it at some stage. Right, now watch the pattern. We're going to count in 20s, making sure that we understand, guys, that 2 times 10 is 20. So each time our number is going to be 10 times bigger, and we multiply any number by 10, it gains a naught. So let's go. 20, 40, 60, 80, 100, 120. Are you seeing the pattern? with the two blue numbers, two blue sets of numbers, 140, 160, 180, 200, 220. Now we are going to count in hundreds. And you will be able to see the pattern again, where 2 times 100 is 200, or 20 times 10 is 200, and watch the pattern again. So 200, 400, 600, 800, 1000. You see the pattern there? 10, and then 100, then 1000. 1200, 1400, 1600, 1800, 2000. Wow! And 2200. Have a quick look at those patterns, girls and boys, and you will see how they interrelate and how they are like family almost, depending on if the one pattern shows it's 10 times bigger than the other one or 100 times bigger. Nicely done. Now let's revise our sharing that we did a whole lesson on once before, and now we're going to bring it into applying this and seeing if we can calculate using sharing. Right, so our little story is going to be involving 3 little friends, and there they all are, cute little girls all playing together, and this is their story. 3 friends share 393 Rand. Wow, how much money does each girl get? So they're going to share it out equally. They're going to take 393 Rand and share it out. So let's imagine they're all sitting around a little table and they've got their money. Right, so firstly, they're going to have 300 Rand in a pile, and then they're going to have 90 Rand, and then they'll have 3 Rand, which will be 3 1 Rand coins, 3 100 Rand notes, and 9 10 Rand notes. And of course they've got to have the same purses because girls like to have the same thing. So now they're going to share the 300 first. And what do they each get? 100, then 100, and 100. And we have now shared out our 300 of the 393. But now they've got to take the 90 and share that out. You notice how we split our numbers up, grade 3s, when it suits us. Excepting when we do lock and split and subtraction, we lock that first number and split the second number, just to remind you. So let's split up 90 Rand between 3 friends, means they will each get 30 Rand. Cool. And then the 3 1 Rand coins, well, they each get, do you see an error here, guys? There's an error there. They each should get 1 Rand, and I said 3 Rand. So my answer there should not be 133. It is 131. Can I just show you that again? If I use my laser pointer, here I have 3 Rand, and Mrs. Harwin didn't check her PowerPoint properly before I presented it to you. But it's a good lesson for you to see that we all make mistakes and that we need to correct them and just make it right. So that 3 Rand there, guys, as I just said, oh well, I was just careless and I said 3 Rand here, 3 Rand here. No, can you see why that is wrong? Because that means that there was 9 Rand here, and that's not correct. There was only 3 Rand, so I made an error. So this here should read 1 Rand coin, 1 Rand coin, and another 1 Rand coin. So the answer will not be 133 grade 3s, it will be 131 Rand each. And let that be a lesson that when you're doing a calculation, especially a word problem, it really does make sense to go back and check it much more carefully than I did this particular one. I checked every other slide, but not this particular one, because it just looked right to me. And sometimes just because it looks right does not mean it's right. And that's what I always tell my classes, guys, don't look and see if your problem is pretty. It is pretty. It looks pretty good to me, but look at that little mistake. I should have checked that and thought, have I split up 3 Rand correctly? No, Mrs. H, you did not, but you made it right. Okay, so we need to learn from all our errors, and that's one of my biggest things in my life. I have made quite a few mistakes, so I learn quite often. Right, so now we've done sharing. Let's go on to grouping. Okay, so sharing was like dividing, splitting things up. Grouping is grouping, and it's where it leads to multiplying. So look at our word problem here. Mom has a lot of cupcakes to bake. This just sounds typical mom, doesn't it? Our moms are amazing. She needs to pack 6 cupcakes into 4 boxes. How many cupcakes does she need to bake? Right, so let's have a look. How are we going to set this up? Well, firstly, I need to know how many boxes have I got to pack for. So let me create those 4 boxes. There they are. Do you notice the visual? You are drawing it. So if you were doing this problem, you would draw a box. Draw 4 boxes, obviously. And then you would pack 6 cupcakes into 4 boxes. Let's do that now. And the first box gets 6 delicious cupcakes. There it is. There's the number, the picture, and then we represent it with a number. Next box gets 6. Now do you see how this word problem makes so much more sense when you're looking at it in picture form? Guys, this is so important when you are creating solutions to these sometimes complicated problems. And sometimes you think, I don't know how to start. Well, start with drawing. Now, the next box will get 6. And there we'll write up our third little number 6. And our fourth box gets 6. And there we have it. We've drawn it and we've written our numbers. And what do we get as a solution? 4 times 6 equals 24. And there we go. So Mom has a lot of cupcakes to make. She needs to pack 6 cupcakes into 4 boxes. How many cupcakes does she need to bake? She needs to bake 24. Great. And next mixed bag example is fractions. And we did fractions before, remember? We did quite a lot on fractions. I think we did 2 lessons on fractions, if I remember correctly. So now I'm going to build on that and we're going to revise it. We're going to go back to it and just check that we remember everything. Right, so for instance, we've got 3/4 written there. Remember I told you before that 3/4 tells a story. Oh, yes, it does. So when you see a fraction like that, guys, you need to be able to tell me quite a lot about it. So firstly, you know that the top number is called a numerator. It's quite a big word. And the bottom number is called denominator. Those are very big words. And how are you going to remember that the top one is a numerator? That NU are the first 2 letters of numerator. So NU stands for never under. And D, the capital D, stands for the word down. So the denominator goes down. Right, and what does 3/4 mean? Well, it means 3 out of 4. And that little line there, you think it's just a little line, it's a little stripe. No, that means something really important. It means 3 out of 4. And I'm repeating myself, but that's what teachers do best, is to repeat themselves. Right, let's continue. So if I had to describe this fraction 3/4, and you can apply this to any fraction, grade 3, I would explain it like this. This is story sum, or the maths explanation. I cut a cake into 4 equal parts, and I eat 3 out of the 4. So what is the fraction I've eaten? I eat 3/4 of the cake. And that is it, simple in a nutshell. That's why I remember telling you before, you have got to understand the very basics of everything to do with a fraction. What does the top mean? What is its name? What does the bottom mean? The bottom means I took a cake and I cut it into 4 equal parts. And the top part tells me I took 3 out of the 4. And now you know. Once you know that, that is going to set you on a fabulous fractions pathway. So let's carry on. Right. So here is a fractions chart or a fractions board. And this shows us some really interesting information. Right, you've got 1 whole chocolate, then you've got 2 halves, then you've got 4/4, and then you've got 8 eighths. Remember, 2 halves, is a whole. There you can see it. You can see it in the picture. 4/4 the same as 1 whole. 8/8 is the same as 1 whole. 1,000,000 millionths is the same as 1 whole. So let me put a little question to you. If I eat half of the chocolate, I eat this amount. Okay, I'm actually going to circle that with my pen, with my highlighter. If I eat, oh, not that one. If I eat half a chocolate, okay, and you eat 2/4 of a chocolate, let me change that color quickly. I'm going to make it a bit bolder. Right, so you eat 2/4 of the chocolate. What do you think the question's going to be? Do you think you'll know what the question is? Who eats more? I ate half the chocolate and you eat 2/4. We both eat the same amount of chocolate. What I explain to my class is to make them remember, because I like you to remember things by thinking of pictures in your head. So if Mrs. Harwin eats half a chocolate, it means she kind of possibly sticks the whole half into her mouth. Whereas somebody else, you eat 2/4, you eat the same amount, you just eat it in 2 separate pieces. All right. So we say, and now here's another big word for you, grade 3. We say then that 1/2 is the same as 2/4. Or if we use a really big maths word for cleverness, we say that 1/2 is equivalent, which comes from the word equal. It means it's exactly the same, and you can see there it is. Now, what comes next? Word problems. You're going to be whiz kids at word problems. I promise you, if you're given the right skills and the right way to handle them, you're going to be kings and queens and princes and princesses of word problems. Right, let's have a look at what this one is. Remember, what do we need to do? Read carefully and underline the question. Remember these instructions and you won't go wrong. What do we already know that we've read in the word problem? What do we still need to find out? And to help us know that or find that out, we need to highlight the numbers and circle some of the keywords. And sometimes there aren't keywords, but if there are, then we solve the problem the best way we can and write our answer sentence, and then we check the answer so we don't make mistakes. Let's have a look at this particular word problem. A farmer picks 356 apples on Monday, and then he picks 287 apples on Tuesday. How many apples does he pick in total? So my first instruction is to read carefully and then underline the question. What's the question? How many apples does he pick in total? What's the key word? We are going to find the total. When we look at the word total, it means we're going to find all together. How much all together? Now I'm going to change my color again, and we are going to circle our numbers. There's 356 on Monday, 287 on Tuesday. So how many did he pick all together in grade 3? So I'm now going to solve that problem. I know that I've got to add them. Okay, I know that probably the best way to add this is to add numbers in their families. There's 2 ways to add. Well, there's more than 2 ways, but at the moment I am focusing on 2 ways for the moment. You'll learn lots of different ways later on. But I'm going to add them in families. So I'm going to add my hundreds family first, my tens family second, and then my units or ones family third, and then I join them all together. Because remember, if you split a number, you have to join it all together. So here goes. 300 plus 200 is 500. Perfect. Now we've got to add our tens. 50 plus 80 equals, and if you're struggling to do this, then you're just going to add on and start at your bigger number. It's a lot easier and less time consuming. So you're going to add on in tens, and you will find you'll get to the answer of 130. There we go. I've added my hundreds family now, and I've added my tens family. Now I'm going to add my ones. So 6, that's in the units or the ones column, plus 7 equals 13. Now, guys, that is not a proper number complete in its answer form. So in its answer form, I need to now combine these numbers. I've got to bring it back to one number or one solution. How do I do that? Well, step by step, because that's what maths is, step by step by step. 500 plus 130 plus 13 equals 643. Whew, that was a relief. I was a bit worried I'd made another mistake. Oh my goodness, then I would be in trouble. Not really, because mistakes are not a big deal. You always make mistakes when you try, but I shouldn't have made that mistake. I should know better. And so now I write my sentence. Remember, I said you must write your answer sentence. My answer sentence is because I have got a question. Here's my question. Over here. There's my question. And I now need to answer it. Just because it's maths doesn't mean to say I can't answer it. So the answer is the farmer picks 643 apples in total. And now let's do our puzzle finisher, guys. So this is quite fun, isn't it? I love these. I always tell you that, don't I? So first of all, what do we know? This is also like a word problem in a sense. What do we know? We know that this little juicy red apple has a value of 7. And my next question is, the bunch of grapes' value, or the value of the bunch of grapes, is the same as 5 plus, well, the apple is 7, obviously. So 5 plus 7 is what? 12. So the grapes is the same as 12. Right, now we're going to fill in what we already know. Again, solving a problem, we need to fill in or find out or identify what do we know. Well, we know that the apple is worth 7. So 7 is the same as 1 plus what? Well, 1 plus 6, isn't it? Interestingly enough, look at that banana, or those 3 bananas. Each banana must be worth 2, because there are 3 bananas. So 3 times 2 is 6, or 2 plus 2 plus 2 is 6. So now let's fill in what we know to complete this puzzle. We have 7 plus 12, and then the banana, there's only 1 banana, so it's not 6, it's 2, because each banana is valued at 2. So those numbers added together, well, 7 plus 12 is 19, plus 2 is 21. Brilliant. Right, so grade 3s, that obviously is the end of this particular maths lesson. And thank you for joining me, and thank you for listening so beautifully. And I hope that you're really learning and that you're gaining confidence in maths, grade 3s, because if you understand the basics, it really gets better and better and better. It's when you don't get the basics and then you go on to the next step and you go, oh, I didn't know, I don't understand this. So we must go back to the basics, and that's what I end up doing. So grade 3s, with lots of love, I say goodbye to you now, and say that I look forward to meeting you in our next lesson. And for me, from me to you, lots of love and a cheerful goodbye, grade 3.